right, hey guys, it is Miss Lastly and Miss Markert, and we are here with day number 12 of our unit, and we're going to talk about something called the binomial theorem, which is a little bit intense, but we're going to try and go through it a couple different ways so that you can kind of get the hang of it, and we're going to do more of this tomorrow. So this isn't our only day we're going to talk about binomial theorem. We're going to look at it again tomorrow and show you a couple more tips and tricks. But it is, it's a little intense. And so hopefully we explain it well, but if not, if you have questions, put them in the discussion board for this week and we will answer them when we can. All right, Ms. Markert, your turn.
Yes, so today you are learning what the binomial theorem is, and we are going to expand binomials, find coefficients for specified terms, and then find nth terms for different expansions. So we're going to start with this example here, and this will kind of help us build into what the binomial theorem is. So we're just going to expand the following here. So if we have a plus b to the 0 power, remember that anything to the 0 power is just 1. So this is going to be 1. And then a plus b to the first power is just going to be a plus b. And then a plus b squared is going to end up being a squared plus 2ab plus b squared. And then this one is a to the third, 3a squared b plus 3ab squared plus b to the third. Remember that when you square binomials, it's not just a squared plus b squared. And same with the third one, it's not just a cubed plus b cubed. You actually have to multiply them out. But yes, so this is what we're going to get. Normally, I would ask you guys what the pattern would be, but you guys aren't here. So I'm just going to tell you what the pattern is, but normally I would be asking you what the pattern is. Okay, so the pattern for the exponents, if you look closely, is if you look at the a terms. So let's just look at the third one because it's the biggest one. So a cubed plus 3a squared b plus a b squared plus b cubed. So if you look at the a terms, we can see that so 3 to 2 is minus 1. So we have minus 1. And then 2 to 1 is also minus 1. And then technically here we would have a to the 0 power, so this is also minus 1. And then if we look at the b terms, we would have a b to the 0 here. And then we would add 1 to get to b to the first, and then we would add another one here. And then we would add another one here. Okay, so the a terms, if you look, we're starting, so we have the third expansion. So we are starting with what n is. So that exponent is 3, and that's n. And then you're subtracting 1 all the way down so you get to 0 in the last term. For the b terms, you start with 0 and then add 1 until you get to what your exponent is in the last term. And that's the pattern for the exponents. So then we need to talk about what the coefficients would be for an exponent of 4. So if we look at all of our expansions here, if we were to write them out, we would have 1, we would have 1 and 1, we would have 1, 2, 1, and then we would have 1, 3, 3, 1. So there are all the coefficients for our expansions that we have there. So if we were to look at what the coefficients would be for an exponent of 4, we would have 1, we would have a 4, and then we would have a 1 here, because if we follow our pattern, we would have a 1 on either side. And then we would have a 4 here and a 6 here. This is called Pascal's triangle, and the pattern here is that 1s are always on the outside. And then this row is your counting number, so you're just going to add 1 every time. And then there's a couple different ways you can look at how the next patterns work. I would kind of look at it and figure out one that works for you, because otherwise it's going to be a little bit confusing. But if you look at these, 1 plus 3 is 4, same here, and then 3 plus 3 is 6, and so that's how that one would work. So our next one would be 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is also 10, and then 4 plus 1 is 5, and then we end it with a 1. So you just kind of add them down, and that gives you your next row in Pascal's triangle. So when we're expanding our binomials, you can use Pascal's triangle to find the coefficients for your expansion. Yes. Anything to add, Miss Lassie?
No, just the pattern. Some of you guys, I know in Algebra 2 did Pascal's triangle for one of your projects, so hopefully you've seen this pattern before. But this just gives you an easy way to find the coefficients of a binomial to a certain power, right? Like if you had, like we deal with a plus b squared all the time, but like what if you had a plus b to the power of 7? Do you really want to multiply 7 binomials together every time? No, absolutely not. So this gives us an easy way to find those coefficients that are going to go in front of our in front of each of our terms. And like Ms. Markert said, the pattern for exponents, the exponent of your first variable is going to start at the highest, and it's going to go down by 1 every time. And then your second variable, it's going to start at 0 and it's going to go up 1 each time. So if you can remember these patterns, so the patterns for the exponents, and then the patterns for the coefficient, which you could use Pascal's triangle for, it's going to make expanding binomials so much easier, right? Like even when you had to do like a plus 3 to the power, or a plus b to the power of 3, like you don't want to do that by hand. Like that's a lot. Like you have to get your little box out and do your little multiplying, and nobody wants to do that. So this makes expanding binomials way easier. Now, if you don't like the pattern, like if you don't like Pascal's triangle, we are going to show you guys another method, which is called the binomial theorem, because we're dealing with binomials, duh. But but if you don't like either of those methods, guess what? You can always just expand by hand if this is confusing. Now, I never would recommend that because you're going to make a mistake, but we're just making expanding these binomials simpler. So yeah, so Pascal's triangle is a really good tool. The only downside for Pascal's triangle is, what if you have like an exponent of like 15? Do you really want to build Pascal's triangle down to 15 rows? The answer is probably no, right? So if you're dealing with something that has an exponent of like 3 or 4 or 5 or maybe even like 6, right? It's not that big of a deal to build your Pascal's triangle, right? But nobody wants to do this, say if you had to the power of 15, which is why the binomial theorem kind of makes it a lot easier. So I'll let Ms. Markert talk to you guys about binomial theorem. I know the binomial theorem is going to look scary. Trust me, it looks scary. It's not scary. You know all the different symbols. It just looks weird put together. So I'm gonna forewarn you about this. I know you're gonna spaz, but it's okay. You can do this.
Okay, yes. So the binomial theorem, like Ms. Lashley said, will help us determine the expansion of a binomial, duh, because it's the binomial theorem, if you don't want to use Pascal's triangle or if you have some really high exponent. So that's just what it is. It's just going to help us determine the expansion of a binomial. Okay. So this is the binomial theorem. So we have x plus y to the nth power. So a binomial to the nth power. And this is going to equal the summation. And then we have n on top, k is equal to 0. And then we have n factorial, which we talked about yesterday. So if you didn't do factorials yesterday, go do those if you are confused. K factorial, and then we just have our binomial here to the K. Okay, so it looks intimidating, but it's not that bad. You know all the symbols. Unless you didn't do factorials yesterday, then go do that. But this is what it is. The one thing I will say here is that if you are in some other class, I don't know if anyone would ever see this, but this piece right here is sometimes written as N choose K. I don't think you're ever going to see that in this class, but if you ever see that in some other class, just know that that just equals that factorial piece right there.
You'll see that piece. Wait till next week.
Oh, I guess you will see that piece next week, but fair warning, that's what that is. But for now, we're just going to stick with the factorial piece. But yeah, that will pop up. It's just a cleaner way of writing it that doesn't look as intimidating, but we'll talk about that later. Okay, so K here is your start term, because remember this is just a summation. N is the term you go to. So when you're expanding binomials, for each term, that's what K is. So like if you had, for example, if we were talking about, I don't know, the A plus B cubed right there, for each coefficient that you would do, you would take your K, so that's the term number. So here we would have, if this is term, does that count? That's term 1. Yeah. So that would be your K value for that one. Is that term 1 or term 0? Because in Pascal's triangle, that's what?
It's the first term.
It's the first term. That's what I thought. Okay. Sorry. In Pascal's triangle, that counts as row, and it doesn't matter. So that is the K piece that you would plug in there. So for each term, so you would use this for every term, and you plug in whatever term number you're working with, that is K. So your term number equals K. Ooh, term number equals K.
Your term number equals K plus 1.
K plus 1.
Have a 0 term
right.
of a thing. So when you're thinking about it, like you're going to see problems on your homework that say like, find the third term of the expansion. Well, the third term would really be when K is 2, because K starts at 0. Like think about a binomial squared, right? So if you have like x plus 3 to the power of 2, you end up with 3 terms, even though your exponent is a 2. That's because you have that first term when K is 0, right? So K would start at 0, go to 1, and then finish at 2. So you get 3 terms, even though your exponent is only 2, right? So when you're doing this, K is always 1 less than your term number because it's starting at 0, but we don't have a 0 term when we're looking at a expression, right? We have the first term, we have the second term, we have the third term, right? So that one gets a little funky, and there's going to be a couple on your homework that are going to stress you out, but just remember the term number. So if I say find the second term in this expansion, it's really going to have a K value of 1 because K is always 1 less than your term number.
Yep. Cool. So with that all being said, let's do the first example. Okay, so I don't know about you guys, but I definitely don't like doing that by hand because that looks disgusting by hand. So we're just going to do that by hand. Now, since we have the 5th exponent there, an exponent of 5, I'm going to just use Pascal's triangle to find our coefficients, and we found them up here. So let's see, this this row right here would be our coefficients for this one because that's row 5. So our coefficients are, and sorry guys, sometimes I forget that you guys can't see my screen that I'm writing on. 1, 5, 10, 10, 5, 1. So what you're going to do, and then you're just going to follow the pattern that we talked about up above. So we're going to take 1, and then we have x to the 5th, and then 3y to the 0. And now if you know that 3y to the 0 is just 1, you can leave that off just so that people can see what's happening in the pattern. I'm going to just leave that in, but if you get it, you can totally leave off the 3 to the 0. It doesn't really matter. And then we have 5 x to the 4th, and then we have 3y to the 1st power, and then we have 10 x to the 3rd, 3y squared plus 10 x squared, 3y to the 3rd plus 5x 3y to the 4th plus 1x to the 0, 3y to the 5th. Yep. So that is our expansion. We haven't simplified it yet, but remember our first term, or our first part of that binomial, is the exponents are counting down by 1 until we get to 0. For that second term in our binomial, the exponents are counting up by 1 from 0 to 5, which is our exponent that we have on our binomial. So now we just have to go through and simplify it. And since I trust you guys know how to simplify that, I'm just going to show you what the answer is because I did it this morning to make sure that I didn't make a mistake, because this gets a little tedious. Y squared plus 270 x squared y cubed plus 405 xy to the 5th plus 243y to the 5th. Ooh, that's ugly. To the 5th. And that is our expansion for x plus 3y to the 5th. It's not that bad. It's maybe
be careful, guys, when you are raising your things to the different powers. So like, for instance, when you have, like, for the third term where we have like 10 times x cubed times 3y squared, remember, you're also squaring the 3. So this is going to be basically become 10 times x cubed times 9y squared. So just be careful. I see a lot of mistakes because people forget to apply the exponent to the numbers inside their parentheses. So just be careful. Generally, if your numbers are not coming out correctly, the problem probably is that you forgot to raise your coefficients to that exponent. You probably just did the variable.
Mm-hmm. Yeah, that is one thing that we do see a lot. So don't forget that. And also don't forget to put parentheses around that whole second term. So 3y is your second term. So that has to go inside whatever exponent you have in that term. All of that is to that exponent. So don't forget about that. You can't just pull that 3 out because there isn't a 3 on the x. So that is all part of that second term. Okay, so the next thing that we're going to do is find the nth term of x plus 7 to the 6th power where n equals 3. So we want to find the third term. So remember, just like we talked about earlier, so we're going to actually use the binomial theorem for this one. So remember, we have that k piece, and to find k is 1 less than n, so k equals 2 here. Now, to find this piece, I'm going to use binomial theorem. So remember that we have the summation. Ooh. This is k, this is, and then we have the 6, ooh, sorry, that is an n, I'm looking at the wrong thing. N factorial, and then we have n minus k factorial and k factorial, and then we have x n minus k. So for this one, we don't really need that summation piece because we're just finding one term. So we're going to take our factorial piece and we're going to plug in all of our information that we need, and then yep, go from there. Okay, so n here is our exponent. So we're going to take 6 factorial over 6 minus 2 factorial, 2 factorial. And don't forget that you can put that into your calculator so you don't have to do that by hand. Remember that a factorial is math, and then you scroll over to the probability, and then you hit number 4. So you can put that in your calculator. Remember to put parentheses around that whole bottom piece if you do put it into your calculator. Otherwise, you're going to get some weird things going on. Okay, so then we have x, x to the 6 minus 2, and 7, because that's our second term there, so 7 squared. And then this is going to equal, so that factorial piece actually equals 15. And then we know that 7 squared is 49. And then we have x to the 4th. And this simplifies to 735 x to the 4th. So in our expansion, our third term would be 735 x to the 4th. Just like that. So again, looks intimidating, not that bad. Okay. So for this one, we are going to find the coefficient a of the specified term in the expansion of the given binomial. So again, for this one, we're going to use the binomial theorem. We need to figure out what k is, though. So to find k, when you're asked to find the coefficient of your term, so we know that n minus k has to equal 3. So k here is equal to 3. So again, we're going to plug all this in. So remember that n is just your exponent. So here, and then we're going to just do the same process that we did above. So there's k, and then we have x, 6 minus k, and then we have negative 2 to the 3rd. So this negative is attached to that second term. So negative 2 cubed. Okay, so then I put that into my calculator, and I get 20. Negative 2 cubed is negative 8. And then we have x to the 3rd. And then we are only asked to find our coefficient, but since we have x cubed there, we can just write it. So our coefficient for this one would be negative 60 x cubed, or sorry, negative 160 x cubed. Yep. Okay, that's all the examples I have for you guys. This is your homework for tonight. It's pretty much what we just talked about. Expanding the binomials, finding the specified nth term in the expansion of the binomial, and then finding the coefficient a of the specified term in the expansion of the binomial. I think just like last night, I think because I did an example of all of these, I'm going to leave you guys to practice these. Remember, if you have questions, you can put them in the discussion board. The one thing I do want to point out is on number 8, we do already know what k is because it gives us k. So just remember that we do know here that this is k. So don't, I mean, if you get confused, you can just find what k is, because 10 or 8 plus 2 is 10. So you would be able to find what k is, but work smarter, not harder. I think should be pretty good. Did I forget anything, Miss Lastly?
No, I think that's good. This is definitely a tough topic, guys. So if this video isn't enough, remember you have the internet. You can check out Khan Academy. Mathisfun.com is a pretty good website if you're having a hard time. But
Wolfram Alpha usually has some good stuff.
huh?
Wolfram Alpha usually has some good stuff too.
Yeah. But we are going we're going to talk about this more tomorrow. So if you're confused, you're having a hard time with it, that's okay. We're spending 2 days on this. So we're going to talk about it some more tomorrow. And maybe address, like, if you have some questions, definitely try the homework. And if you have questions, post it on the discussion board. So we'll try and put some of the questions from the discussion in tomorrow's video. But hopefully you guys should be okay. I think Miss Marker did 3 good examples that should help you do your homework, right? And the homework answer keys are posted. They're posted in the same spot they normally are. You just want to go to Miss Marker's OneNote class notebook and go to the page that says day 12 homework. So they're always posted, so you can check and see like how Miss Marker worked them out, that kind of thing. All right, so until tomorrow, that is what we have for today.
Also, if the PDFs don't show up for some reason on this week's stuff, I'm going to try and fix that. But if they aren't working, let me know and I'll try some other way of fixing it. Yeah, that's it.
All right. Bye, guys.